They're both such good vocalists.
Love that.
And then
every time gives me
A person couldn't give it a cold.
and Malcolm's playing nicely.
Nice.
And then
Who's Sky? Sky Mexican.
Christian.
Oh, Christian.
Yeah, he played SpongeBob last year.
And Adam and TC last year. Which it was absolute shock to me when I saw him on stage with SpongeBob because he was so quiet in here.
Yeah, I remember you.
I was just like, huh?
Because we were talking about it when you saw the.
Yes. Yeah. I was gobsmacked. All right, we are going to practice writing some more inverses. So we're going to find the inverse. Our first one up here, we've got our f of x equals 6 plus x over x. So when we're writing our inverses, first thing we want to do is we want to switch it out of its function notation so that we have x's and y's. It is really, really hard to do this if you keep this in function notation. Not saying it's not possible, but it is like super duper extra challenge mode for no reason. So switch your f of x out to be a y. It makes it so much easier. I promise. Please. Please do. So switch your f of x out for a y. Then we're going to take the letter y and the letter x. Every single letter x gets replaced with a y. Every single y gets replaced with an x. So to make our inverse here, we're going to write this as x equals 6 plus y over y. And we want to try and get this to be a y equals. That's the whole goal. So we want to be able to put this in function notation. So if I want to get to be able to write this as a y equals, I need to get that y out of the denominator. For sure. How can I get that y out of the denominator? Multiply both sides by y. So if I times this side by y and this side by y, we're going to have either x times y or yx equals, those guys are going to cancel out, and we're left with just 6 plus y. So we've lost our fraction here. Now I have y's on both sides of my equal sign, which is a little weird. So what I want to do is I want to get my y's together. So what I can do is I can actually minus y from this side, which means I also need to minus y over here. It's not going to cancel out. But we are going to get xy minus y equals 6. Can we see how we can get our y's to combine together into 1 here?
Think of this as, do we have a GCF here?
Yeah.
Of y.
Factor out a y. We want our y's on the same side of the equal sign, and then I can factor out a y, which is going to give me x minus 1. Y times x minus 1 equals 6. Well, now if I want to get that y by itself, divide by x minus 1. So our y is going to equal 6 over x minus 1. So the inverse of 6 plus x over x is 6 over x minus 1. So this is our inverse of f of x. So f inverse of x, 6 over x minus 1. Okay. We're going to practice a couple more of these. We'll do at least one more rational in here. I want to show you a couple of the weird ways they're going to write problems down for us. Before we get too far on this, let's think about our domain and range here. What is the domain on our f of x up here?
Negative infinity to 1.
Ooh, not 1 on the domain here. This one's our 0. This is when we have our vertical asymptote. So it's x equals 0. So this is our negative infinity to 0, 0 to infinity. Our range is going to be that ratio of our leading coefficients, 1 over 1. So it's going to be everything except positive 1, negative infinity to 1, 1 to infinity. So looking at our inverse down here, when we switch those, our domain being the negative infinity skipping over 1, that is exactly what we would get if I looked at this all by itself and found my vertical asymptote. It's exactly where our 0 is in the denominator. And using that same ratio of our leading coefficients, we'd see our horizontal asymptote is going to be exactly at 0, which is exactly what we get when we switch our domain to be the range here. So the fact that our domain and range flip matches exactly up with the function that we have. So our range being everything except 1, everything except 0, absolutely fits this equation as well. And I know I'm squishing that in there, I'm sorry. But the domain and range flip-flop back and forth, and that should match up with the function you get. We shouldn't have to manipulate it to do so. Where we have our asymptotes is exactly what we get when they flip. So it's a nice way to kind of spot check or double check. I mean, you kind of need to find them anyway. Questions on this first one? Okay. Because sometimes they give us a weird piece with it. So they've told us now we're going to look at g of x as x squared plus 2. And then off to the side, they say x is greater than 0. Or greater than or equal to 0. What this is telling us we are not going to use the domain for a normal parabola that could go from negative infinity to positive infinity. We are only using the domain when x is 0 or larger. Because we're trying to find that inverse, and we want our inverse to be a function, I cannot use the whole parabola. It is not a one-to-one function. If I did my inverse, it would turn into a sideways parabola, and that is not a function. I failed the vertical line test. So in order to take my parabola and make it be an inverse, I have to only look at part of it. That's what the x greater than 0 is saying, is we're only looking at the one side. So that when we take our inverse, and I get my square root, it's still a function. So when we're looking at this, genuinely, it doesn't change anything we do, except that our domain is not going to be negative infinity to positive infinity. It's going to be from 0 to infinity. That's the only thing that changes. Our range we could figure out. What's our range going to be? Is it going to go all real numbers for my parabola? So if we had an x of 0, what's our y? 2, right? So even if x is 0, 0 squared plus 2, our range is going to start at 2. That's going to be our lowest possible point. Every other value is going to be bigger, so it's going to go all the way up to infinity. So when we have a restricted domain, think about what that first point is and where that puts our y's. So from here, I'm going to see, I can find my domain and range of my inverse right now. I don't need to, but I could. We're going to actually find our inverse function. So first thing I'm going to do is I'm going to take my g of x and I'm going to switch it to be a y. Y equals x squared plus 2. Then we're going to make our inverse. This is the step that makes it an inverse. I take my letter x and my letter y and we make them change places. X equals y squared plus 2. That's now the inverse. It's just not in a way that we like to write equations. It's not in a way that I can put as function notation. We don't put equations as x equals. We want them as y equals. So I need to solve this to be a y equals. And what can we do to make this be a y equals? Subtract 2. So we're going to have x minus 2 equals y squared. Still want to get this to be a y equals. Square root both sides. Y equals the square root of x minus 2. When we're dealing with functions, we don't need to put the plus or minus. Because we're only going to deal with that positive one unless we have some weird transformations happening. So unless we specifically tell you otherwise, you can go ahead and just put the positive square root, that principal root. This gives us our inverse. This guy right here is the inverse. So our G inverse of x is the square root of x minus 2. They're inverse functions. And in here we can see our domain, exactly what we expect it to be. My x has to be 2 or bigger, otherwise we get imaginary roots. So our domain's going to go from 2 to infinity. And the answers we're going to get when we substitute in numbers from 2 to infinity, our smallest possible option would be 0 all the way up to infinity. So it's exactly what we expected when we switch our domain and range up here. So when they give you a restriction like this, or a little piece like this, where they say x is greater than or equal to 0, all that's telling us is that's our domain, not whatever we think that function should be. It's limiting us down to the point where it is possible to take the inverse. When we do it ourselves, it's because we're taking our square roots and finding inverses to be squares, and that's why we find our domain and range, is it's finding that domain restriction for us as we're going through it. Questions on this one? Two more like this, or two more inverses. I want us to do another fractiony one because they're a little scary and weird. I put them in between there so we didn't do them right after each other. We're going to do another rational. Here we have our f of x equals 4x plus 5 over 3x minus 8. You can find our domain and range first. You can start finding your inverse function first. It doesn't really matter what order we go in. It doesn't change the process if we know the domain and range, and it doesn't change the process if we do our inverse first. So thinking about our domain, that's when we want to know our vertical asymptote, so I know what's affected with my x's. Where's our vertical asymptote going to be? Say it a little bit louder. 8/3. I'm an old. My hearing has been weird today. So yeah, it's everything except 8/3. So everything from negative infinity up to 8/3. And from 8/3 all the way up to infinity. You could also, I'm okay with you putting like x cannot be 8/3. If you want to put it as a not equals to, that's okay. I'm just in the habit of writing it in interval notation. What's our range going to be? What's our horizontal asymptote going to be? 4/3. It's that ratio of our leading coefficients. So it's everything except 4/3 in our domain. Or sorry, in our range. So we jump over our 4/3 and we call it good. So from that alone, I could have my domain and range of my inverse. We're actually going to find our inverse, and then I'll write it down. So finding our inverse, I'm first going to write it with our y. Y equals 4x plus 5 over 3x minus 8. Then I'm going to find my inverse. Switching my x's and y's, that's when it turns into our inverse. My x equals 4y plus 5 over 3y minus 8. What should we do first? Multiply both sides by that denominator. I'm going to take my 3y minus 8 times this side and my 3y minus 8 times this side. So I'm multiplying by my denominator. That piece and that piece are going to cancel out entirely. So we're going to be left with our 3y minus 8 times x equals 4y plus 5. What should we do next? We're going to need to get rid of these parentheses over here. So I need to multiply my 3y minus 8 times the x. I want to be able to have just terms with y's on this side and everything else on the other side of my equal sign. I want to have just things with y on the left. So we're going to start by distributing out this statement. So we're going to have our 3yx minus 8x equals 4y plus 5. Ew. I want to get things that have y's on one side and things that don't have y's on the other. So what do we need to do? Subtract 4y from both sides. Anything else we want to move on that step? We can add the 8x on both sides. I don't need to have the 8x on this side. I want to have stuff with y's over here. So we're going to have our 3yx minus 4y equals 8x plus 5. Surprisingly enough, we are very close. I got all my things that have y's together over here. Why did I want to do that? What can I do with this now? Factor out that y like a GCF. Exactly right. So I want to take that y out as a GCF, giving us 3x minus 4 equals our 8x plus 5. So what is our y going to equal? 8x plus 5 over 3x minus 4. So our inverse of f of x, f inverse of x, is exactly that fraction. Our 8x plus 5 and our 3x minus 4. And if we switch our domain and range, that's exactly what we expected to be. Our domain up here was everything except 8/3. That's exactly what our range is going to be down here. It's our ratio of our leading coefficients. Our range, which is everything except 4/3 up here, is going to be exactly our domain. That's what the zero of our denominator is. So it still matches up with exactly what we expect the function to be. So it's a really great way to kind of double check that we have things where they're supposed to be. Okay. Questions on these ones? I feel like the rationals are the ones that throw us off the most. I'm not going to end on a rational. I'm going to end us on a not quite so brutal one. I'll do a nicer one. Last one that we're going to do of these inverses, and then we'll move on to other things. Here we've got g of x equals negative x cubed plus 2. What's our domain on this one? Odd degree means our arrow's going opposite directions anyway, so it's going to be negative infinity to positive infinity. What's our range going to be on this one? Also negative infinity to positive infinity. This is an odd degree function, so our arrow's going opposite directions, which means my domain goes from a negative infinity to positive infinity. My range goes from negative infinity to positive infinity. Yes, that is the exact same thing as all real numbers. So then finding our inverse, I'm going to start by switching it out for a y. Y equals minus x cubed plus 2. Then switching to get our inverse, we get x equals minus y cubed plus 2. What are we going to do first? Subtract 2 on both sides. So if I subtract 2, that's going to give us x minus 2 equals minus y cubed. What are we going to do next? Yeah, absolutely valid move to divide by -1 next. And you can either write it as negative x minus 2, totally valid, or you can have it be minus x plus 2 and distribute that minus sign through. You could write it as 2 minus x. Ooh, how should I do it in right order? 2 minus x. When we divide both sides by -1, any one of these is an option. It genuinely does not matter which option you use. I'm going to go ahead and put it as the 2 minus x, just because that's the least parenthesesy. So we have 2 minus x equals y cubed. I would 100% take any of these three options for 100% full credit. Totally fine. None of them are wrong. It's just whichever way your brain works better, go that way. One last step. What do I do to get y by itself? Cube root. So we're going to have our cube root of 2 minus x, or the cube root of negative x plus 2, or the cube root of negative quantity x minus 2. Any of those will work. And that's our y, or our inverse of g of x. G inverse is our cube root of 2 minus x, or a cube root of negative x plus 2, or the cube root of negative quantity x minus 2. Genuinely, all of them are fine. That will still have our domain from negative infinity to positive infinity. That will still have our range from negative infinity to positive infinity. Because cube roots look very much like a cube, just on its side and kind of like this. Pushing there. Okay, questions on our inverses? Cool. So that's everything in section 5.1. In the book, they have a kind of bizarre way of breaking exponential functions up into two sections, which logically is a bizarre choice because it's dealing with exponential functions with a base of a number and the base of an e in two separate sections when they really do the same stuff. So I've pushed 5.2 and 5.3 together because they do all the same things. So that's why if you look on the schedule, it has 5.2 and 5.3 in the same block. Because a lot of the things we're going to do are going to mix 5.2 and 5.3 together. The only difference between 5.2 and 5.3 is instead of it being a b as our base here, in 5.3 it's e, the number e. And so we are going to bounce back and forth between 5.2 and 5.3 for all of the days that we're doing that. So we're going to be looking at some exponential functions. And we're going to start with this as kind of our basic form. A lot of times we're going to use this as our basic form where we don't have a k. But I want to put the k in here so that we can think about that and not have to mix that in later. It's a separate train of thought. So we're going to be dealing with exponentials, meaning our x is in the exponent. Our x is the exponent. And a lot of times with these, we're going to wind up with some kind of story problem or like real life situation, at least kind of vaguely. And so what we have here is some pieces that we can use to do this, where A is our initial amount, it's how much we start with. B is how much it grows. So if it doubles, we're going to have a base of 2. If it triples, we're going to have a base of 3. If it grows by 50%, we would have a 1.5 base. We'll talk about specifics on those as we get into it. X is going to be our units of time. When we're dealing with story problems, it's also our exponent. And if we have a k here, that will be a vertical shift or an asymptote. We will very rarely have asymptotes in the story problems, but when we're looking at other parts, there is. Our y-intercept is always going to be based off of a and k. So if we don't have a k, our y-intercept is a. That's going to be where we start. If there is a k, it's the difference between. For exponential functions, they are always going to have a domain from negative infinity to positive infinity. Our range is either going to be from negative infinity to k or from k to infinity. And that just depends on whether we have our positive a value where it's going up or if we've been reflected across that x-axis with a negative a value. Either way, whatever our k is going to be the endpoint of it. So if we don't have a k, that's going to be a 0. I'm going to give us a bit of time to write these down.
Could range not ever be all the numbers?
Not on exponential functions. If you think of exponential functions, these are the ones that look kind of like this. So it's not our rationals where we have both pieces. It's like 2 to the x. I can't have that go negative unless I flip the whole thing upside down. There's a little bit more time to write it down. What we're going to start with on this first one that we're going to look at is we're going to be using just these. It's not going to have a k. I'm going to call it that. So we're going to look at our starting amount, how much it's growing, and what unit of time we're going to use up here. So it's going to be a dun-dun-dun story problem. Luckily, it's only a single sentence long.
Still.
I know. That's okay. For When we do more of them, I will print them out. So, just, when it's just one, I didn't print them out. We're like, yeah, we're going to do one. For tomorrow's, I printed them out. Actually, I love that. I changed my order, so the bottom graph is actually today. All right. I'll give you guys some time to write this down for a second. We'll get into PERT. We will wind up doing PERT. That's when we start looking at ease and stuff like that. We will deal with exponential growth and exponential banking, like those banking questions, the compound interest, those kind of guys. We'll get into those by the end of the chapter. In fact, I think by the end of the week we'll get to those. All right. So this is a very, very, very common science experiment that gets done. This is a real thing people do in science. That we got our number of fruit flies that triples every 4 hours, and there's 100 fruit flies to start with. So we want to try and write an equation for this situation in our exponential style. That's going to be our y equals a times b to the x, the sum exponent. A is going to be our starting amount. What's our starting amount? 100. So that's going to be our A. So we're going to have 100 times, how much is it growing? Triples. So our base is going to be that it triples. So we're going to have 3 to some exponent. X is going to be our unit of time. We also still need to have an x in there. So I want to be able to say, like, x equals 1 for 1 hour, x equals 2 for 2 hours, x equals 3 for 3 hours, that kind of stuff. So I want x equals 4 to be 4 hours. So for my exponent, what can I put here? Ooh, I was going to be, I heard 2 different options here, and that's exactly what I kind of expected. Because we either are going to have 4x or x over 4. I want to be able to say x equals the number of hours. So in 4 hours, what should our exponent be? How many times is it going to triple in 4 hours?
12 times?
Say it triples once every 4 hours. So if x equals 4, I want my exponent to say
4.
So in 4 hours, we're going to have how many fruit flies? If I'm not thinking equation right now, in 4 hours, how many fruit flies are we going to have? 300. Right?
Which includes x over whatever number if it's like.
Mm-hmm. Yeah. So it's tripling once in that 4 hours, right? We have our 100 times 3, it tripled 1 time. So I want, when x equals 4, my exponent to be 1. So if I put this, and my hours are 4, I'm going to triple 16 times. That's not what I want. If I put my x of 4 here, 4 over 4 would give me the one we're expecting to have at 4 hours. So when we have funky units of time, we need to be super duper duper extra careful. Because our exponent here is going to be x over 4. Because after 4 hours, I expect this to triple 1 time. After another 4 hours, so 8 hours in total, it's going to triple again. And then another 4 hours, it'll triple again. So we want to be able to find out how many fruit flies there will be in 24 hours. So we want to be able to put in x equals 24 to be able to find out this answer. So we can do that. When we set this up to kind of type in this equation here, if we have our 100 times 3 to the 24 over 4, we can evaluate this. What is 24 over 4? 6. So this is the same thing if we had 100 times 3 to the 6, because I can simplify that down. That's something we can type in the calculator. What is 100 times 3 to the 6th? 72,900. Just because I have things randomly scribbled out. So if we have funky units of time, we need to be really careful with our exponent. When in doubt, think it through. If my fruit flies are going to triple every 4 hours, I know that in 4 hours I should have 300. And then in another 4 hours after that, I'll be up at 900. So I'm taking my x of how many hours and dividing it by 4. Or you can go, how many sets of 4 hours are there in 24 hours? Well, my exponent should be 6. So you can logic your way kind of through that one a couple of times. That's one of those things that shows up on things like SAT and PSAT a bunch. If it had something like 4x, it would be that it triples 4 times every hour. So if it triples 4 times every hour, then it would be every 15 minutes, I would have 300, and then another 15 minutes, I'd be at 900, and then another 15 minutes, I'd be up at, holy cow, this is way too many gosh darn fruit flies. Please, I don't have bugs. So if it had something like tripling 4 times every hour, that's when we would have this. If we're tripling once every 4 hours, we have to divide it into our chunks. Good question, so guys. So we can use this to kind of help us look at equations and graphs as well. Tomorrow. We'll look at it tomorrow. I'm just going to put that up there. Cut them off, but that's okay. I'll pass them on tomorrow. Just because we are at 3 minutes till the end of the period, and I don't feel like sprinting through it. So we will look at the next bit tomorrow. Working with these exponentials, etc.
Can I get a passport?
Yes.
We have leap show tomorrow.
That's one of the benefits of the leap shows. It works very much like a pre-opening practice.
Hasn't been disclosed which what? Hasn't been said which actors? Nope.
Usually it's act 1 because they want people to come back to see the finale or to see the ending of the story.
It was kind of funny because yesterday during our news meeting at the end,